In this lesson, let's go on to learn the IoT Cloud for Ruff application development. In our two previous lessons, we theoretically explained some basic concepts on the IoT Cloud. In this lesson, we'll focus on the actual operation and explain how to use the IoT Cloud. The IoT Cloud I select here is Azure IoT Hub. The reason why I selected is that in the field of IoT Cloud, Azure is quite extraordinary. Either Service SDK or Device SDK it provides to its developers. Its functions are perfect, and it has good performances as well. Let's first have a look at the diagram of Azure's IoT Hub. The upper half of this diagram, as we discussed before, the three parts of modern IoT application structure, namely the front end, the IoT Cloud, and the terminal. It's worth mentioning that with the Service SDK it publishes to the front-end developers. Azure has developed two front ends for its developers to conduct debugging. They are Device Explorer and IoT Hub Explorer, respectively. The first one, Device Explorer, is actually a GUI tool of Windows, and the other, IoT Hub Explorer, is a command line tool. It must be run under an environment of Node. Next, let's have a look at a course objective of actual operation in this lesson. We are mainly to finish two tasks. And one is that the front end sends a message to the terminal, and the other is that the terminal reports the data. And finally, the data can be displayed at the front end. Both the front end and the terminal will be simulated with the command line. Okay, next, let's configure Azure IoT Hub. At first, a precondition is that we need to install a Node environment on our PC. As we'll use the aforesaid of Azure IoT Hub, which must be run under an environment of Node. Preparation steps. Step 1 is to open the official webpage of Azure and register an Azure account. After registering this account, let's log into the portal website of Azure and create a new instance of IoT Hub resource. Detailed steps are written here. It's actually quite easy. After we create this resource instance, we'll deploy it. After 2 minutes or so, the deployment is done, and we may click this to enter the IoT Hub resource instance. Now comes the most important step. We must get this. Connection string of IoT Hub resource instance. We click to enter a resource instance of IoT Hub. Let's click this shared access policies, and then click the IoT Hub function. Then the third connection string. Click it. Copy the connection string, as we need it in our program later. Next, let's download the SDKs of Azure IoT Hub. There are two, Device SDK and Service SDK. As I said before, all our subsequent operations will be conducted under Node. So this SDK requires the download of npm module. There are mainly three SDKs, Azure IoT Device MQTT and Azure IoT Hub, Azure Event Hubs. After downloading them, we need to create a new device in IoT Hub. It's actually a virtual device, and it refers to our final terminal device. Here, let me give you a demo. First, use the IoT Hub Explorer, and then log into this IoT Hub resource instance. And a parameter here is the connection string we copied just now. After successful login, we use the subcommand create to create a new device, followed by the device ID. We may assign a name to it. Here. It's Ruff Node. Ruff Node 2. Okay. After creation, we get the connection string of this device. Note that this connection string differs from the aforesaid connection string of IoT resource instance. After we well create the device next, we'll realize a simulated acquisition control terminal. Here, it lists some APIs needed for the code. They mainly consist of the following parts. Create a new client for connection to the IoT Cloud, and another is to start connection. Construct a message and then send it out to the cloud. Still, another is to receive the message from the cloud. For details, you may refer to some reference documents for this SDK, which can be found in the NPM website. I've completed writing its program. Now I'll show you this. Not too many codes. Let me briefly explain it. First, I need to add the connection string of this device. Next, we call the client from connection string. Then, create a client. Start connection. After it connects successfully, it will display Connect Successfully, meaning the connection is successful. The following two parts are: one is to send a message to the cloud. I send this message every 5 seconds. The sent message is that I am device, followed by its serial number. If the sending is successful, prints a log of success. The second part is to on a message. Such an event. That means once the cloud sends a message, it enters its callback function, and then we print this message. Next, let's do a test with the front end of Service SDK. I'll still adopt the IoT Hub Explorer to serve as the front end. To start with, we need to monitor the message sent from the terminal. We use monitor events, such a subcommand. Here, let me give you a demo. This parameter is the added connection string of IoT Hub. Okay, it's now monitoring. And then let's execute this simulated terminal. As we see, the connection is successful. In 5 minutes, it prints a log of the person's successful sending. As we see it, it has received this message. It receives the message here. The other is to send a message to the terminal. Here, we use subcommand of send, followed by parameters. One is device ID, and it's Ruff node 2, as we created just now. The other is message. Let me demonstrate the IoT Hub Explorer here. Send Ruff node 2. And then we give a message here. As we observe in this terminal, it has received the message sent from the front end. It's worth mentioning here that here we use node to realize and execute such device file. And we may also realize it through operations of Ruff. Since we have transported Azure IoT Hub, device SDK into Ruff, our main changes are to reduce the size of its entire module and to perform some appropriate clipping so as to guarantee its execution at a hardware where resources are limited. There are 3 main transplanted modules, namely Azure IoT Device MQTT and Azure IoT Device. Still another, Azure IoT Common. A major incompatibility is it does not support the access to Azure storage in this SDK. It's worth noticing that if we want to use this module, do ensure the versions of Ruff OS and SDK are version 1.11.0 or above that. In terms of installation modes, if we want to do testing on PC, there are mainly 2, namely wrap install Azure IoT Device MQTT and wrap install Azure IoT Device. If the 2 packages are installed on this PC, we can do testing on the PC. Here, let me give you a demo. Like before, we monitor the left terminal message. Here, we use Ruff to execute this device.js. As you see, the effect is the same. Let's go on to look at some cases we finished before. Well, let's go on to look at the course objective. In our previous demo, we realized a communication between the IoT cloud and the terminal. We did not use Service SDK as the front end. Instead, we used an existing front end, IoT Hub Explorer. In fact, this module also adopts Service SDK, but it has encapsulated some operations relevant to API. Well, next, let's use its Service SDK to write a simple front end for our solves, to realize the communication between the front end and the IoT cloud. Now, let's move on to the operation part of terminal displaying and operation. Like sending a command to the final device terminal, it mainly involves the following 4 APIs, namely, create a client, then start connection, construct a message, and then send it. Note that, for sending it, it is followed by the service ID. Some reference documentation of Service SDK can be found at the NPM website. Search the Azure IoT Hub Kit there, and then view its relevant APIs. Here, as I said before, enter service. Similarly, we open the device with Node. And then check the service sent file. This file realizes the operation part of terminal operation and display. We want to send a message to the final device terminal. To start with, I need to fill in a connection string here. This connection string means the connection string of IoT Hub resource instance. Let's copy it. And then create a new client. Then add the desired terminal to send. The device ID of terminal is Ruff Node 2. Next, start connection. After successful connection, judge yes or no error. If no error, print a sign of successful connection. Next, send the message. Similarly, send a message to a terminal every 5 minutes. Alright, execute it. Okay, as we see in the terminal on the right, we can see the message sent from the front end. It is sent every 5 seconds. What we discussed before was to send a message to the terminal through the simulated front end, and also to realize control. Next, let's realize the display part of terminal operation and displaying, i.e., to get the message from the IoT cloud, to get the message reported by the terminal device. To complete this procedure, the following 5 APIs are involved, namely, create a client, start connection, acquire a partition ID of Event Hub, and then create a receiver, and then receive the message. Well, all the APIs use the module Azure Event Hubs. For details on the operation of some APIs, we may search on the NPM website. Okay, a real demo is given here. Close it. And then let the terminal constantly under a status of simulation. Let's have a look at Service API. We need to add a parameter here, i.e. the connection string of IoT Hub. After creating this new client, it will make an attempt to connect to the IoT cloud, and then get a partition ID. After it gets the partition ID, it creates a receiver, and sends the partition ID in. After If this receiver is created, it will on this message event. Then, once any message appears, it will print this message. Here, it prints the device ID of this message, and then contents of this message. Well, let's give it a go. Execute it. Alright, as we see, it has received the message sent from the device Ruff Node 2. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much.
Ruff, make IoT easier.